One,
2,
3, let's go!
Hi, item student. This is Engineer Yujei Abat from the MPS department. And for today's tutorial, I'm going to teach you on how to integrate by parts as a part of studying the integral calculus. So if you want to learn, just tune in. Okay, so let's talk about integration by parts. So this is again a lesson about the integration techniques in integral calculus, which is a necessary topic to discuss or to really master, as this will be used in the succeeding subjects in mathematics and even in the major courses. So how do we integrate by parts? So basically, integration by parts will be used to evaluate an integral if we have two functions that are multiplied, okay, such as we have the logarithmic and then an algebraic function. So if they are multiplied and we are getting the integral of that certain function, okay, we need to integrate by parts. Okay, so the formula to use to integrate by parts is given by this, wherein we have the u times the v minus the integral of the v du. Now, we have rules in choosing the u. So we will be choosing the value of u and then get its derivative, okay? And then also, we will be using, or we will be getting also the dv and then integrate to get v. Okay, so priority in choosing u, just like what I've said, when we integrate by parts, we are multiplying two, okay, functions that are different. Okay, so priority in choosing u, there is a priority. This is list from the most priority to the least priority. So that's 1 to 5. So if we have a logarithmic, we can choose that as u, a logarithmic function. And number 2, second one, priority is the inverse function. The third priority is the algebraic function. Fourth priority is the trigonometric function. And the least priority is the exponential. So in this video, we are going to solve 5 problems, okay, to actually indicate or to really show, okay, the basics of computing integration using integration by parts. So as you can see here in number 1, we have ln of x dx, the integral of ln of x dx. So we have a logarithmic function and an algebraic function. Sir, where is the algebraic function? It's actually 1. Okay, 1 multiplied by the ln of x. Okay, so for number 2, we have clearly we have an algebraic function and then we have an exponential. Okay, so the algebraic function is multiplied by the exponential function. Okay, for number 3, we have an algebraic again and we have a trigonometric. And for number 4, we have an exponential, e raised to x, and then we have a trigonometric. Okay, so you see, you can use integration by parts if you see problems like this. We have two functions and then multiplied together. So we have x ln of x, integral of x ln of x dx. So we have an algebraic, and then we have a logarithmic. Okay, so let's try to solve these integrals using the formula uv minus the integral of v du. Don't worry, it's very easy. Okay, so it's basics. So we have the integral of the ln of x dx. So we say that the priority that we should choose for the value of u in our formula should be logarithmic. So, and hence we have a logarithmic here. So, I will be setting u as ln of x. Okay? And I will be getting the derivative of du, which is 1 all over x dx. Okay? So, recall our formula. When we get the derivative of an ln, we use dx over x, or the derivative of the whole function in the numerator, and then copy the same function on the denominator. So the derivative of ln of x is 1 all over x. So, and the remaining, okay, functions inside the integral should be copied by dv. Okay, so we have one here. Okay, that's an algebraic. So we have dx here. So if we integrate both sides, we get v and we get x. And now we can now use the formula of the uv minus the integral of v du. So how do we do that? Simply, this is our u. Our u is ln of x, and that is multiplied to the v, which is in terms of x, minus the integral of v. What is the v? That's x again, this x. And then du, what is du? Du equals 1 all over x dx. So we have 1 all over x dx. So to simplify, we have x ln of x minus, this would cancel, so that we are getting only the integral of dx. And the integral of dx would be simply x. And don't forget, since we are integrating indefinite integral, so we have to add plus c here. So the integral of ln of x dx equals x ln of x minus x plus c. So that's how we do the problem number 1. So using the integration by parts. So guys, I hope you learned something from this video, and it's so much fun solving with you guys. Okay, so again, this is Engineer Abat from the MPS department, wishing you a happy moments in math. And then thank you so much for listening and for taking time in viewing this video. Thank you so much, and God bless you.